So let's try to apply our factor label method to do conversions to estimate the amount of nitrogen that's potentially deposited at Burning Man during the 8 days of the festival. For those of you who don't know where that is, it's about 90 miles, 90 plus miles to the north and east of here in the Black Rock Desert. So the focal point of Burning Man is Black Rock City, and in this image, the image that you just saw, it covers about 12.2039 inches squared on an image that has a scale of 1 to 19,686.44. And what the scale means is this, is that 1 unit of anything, whether it's a foot, an inch, a meter, is equal to, that's on the map, is equal to 19,686.44 units of the same thing on the ground. So in this case, if we have 1 foot, a line that we draw that's 1 foot long on this map, it's going to be the equivalent of drawing a line on the ground that's 19,686.44 feet on the ground. All right? And what we're going to assume, this year the attendance at Burning Man is supposed to be 60,900 people, and we're going to assume that, and they don't all stay for the entire 8 days of the festival. Overall, what we're going to assume is that all 60,900 people are going to attend Burning Man for about 4 days. So they'll be there for, we'll have a maximum of 60,900 people for really a period of about 4 days. And that each one is excreting about 10.15 grams of nitrogen in urine per day. Now there's a reference for that, it comes from 1936, and it's from a paper called The Nitrogen Partition in the Urine of Various Primates. Interesting study. The question that we want to ask ourselves is this: what would be the total expected addition of nitrogen in grams per foot squared of the total area reserved for Burning Man? And we're going to focus, in this case, not on the entire area, which is outlined in this polygon here. This is a Google Earth image of Burning Man. We're going to focus on the area that's really reserved primarily for camping and where most of the people actually stay throughout Burning Man. And that's the area illustrated here in blue. And that area covers, on the map, just on the map itself, about 12.2039 inches squared. And so now when we look at that, we have our scale, 1 of anything, whether it's an inch or a foot, is equal to 19,686.44 of the same things on the ground. We have all the information that we need to carry out the calculation. We have the scale, we have the area on the photo, we have the number of people who attend, we have the length of time that they attend, and we have the average amount of nitrogen that they excrete per day. And what we want, in the end, is the grams per foot squared of nitrogen deposited potentially at the end of Burning Man, or by the end of Burning Man. Another way of saying that is this, is that we have a mass that we want, that would be grams, per unit area. And we're going to get this by attacking this in 2 parts. First, estimating the total mass, and second, estimating the unit area, or the entire area, carrying out the division so that we actually express then the mass in per square foot. And I'll demonstrate that. Okay, we're going to attack this problem then in 2 parts. Remember, there's a top part that has to do with the number of grams of nitrogen. So let's quickly do the calculation related to the number of grams of nitrogen. Remember, there are a couple of key facts there. First of all, there are 60,900 people who attend the Burning Man Festival, and each one can be expected to excrete about 10.15 grams of nitrogen per day. Now, just as a point of reference, this penny weighs about 2.5 grams. So when we're talking about 10.5 grams of nitrogen, that's kind of an important figure, all right? And we're going to expect that those 60,900 people are going to attend. Overall, we'll have about 60,900 people for a total of 4 days out there, even though the festival lasts for 8 days. So let's do a quick calculation about the number of grams, or to demonstrate that, or find the number of grams of nitrogen that we would expect after the whole 8-day festival is over, okay? So we have 60,900 people. Each one excretes about 10.15 grams of nitrogen. So this is people.
people per day, per person per day, and they're there for a total of 4 days. It's set up just like a factor label conversion, no different really. But the first thing we have to do in order to check to be sure that we're really on the right track is to cancel units. So we have people canceling people, days canceling days, and grams of nitrogen is all that's really left. So if we carry out the multiplication, we should end up with the total number of grams of nitrogen that we expect 60,900 people to deposit on the playa over the course of the entire 8-day festival. And that number is 2,472,540 grams of nitrogen. Okay? Now I'm going to erase this because remember what we want is a two-part calculation that spreads this out over the entire area on the Black Rock Desert that's used for Burning Man. Okay? This is a little more complex. Remember one thing. We have an area that we measured on a map, so we have a representation of the Black Rock City on a map. It's 12.2039 inches squared. Remember, it's on the map, okay? But we really don't want inches squared on the map. We want actual number of inches squared occupied by Black Rock City on the playa itself. And this is where our scale factor comes in. And this is where another important point comes in as well. Our scale factor, as you'll remember, is 1 inch, or one of anything, 1 unit on the ground, in this case 1 inch, is equal to 686.44 inches squared. But note, our exponent says that this is square inches, not inches. This is taking a linear measurement on a map and converting it into a linear distance on the playa. In this case, though, we're going from an area to an area, which means that we have to square our conversion factor as well. But look where we are. We cancel up to this point, taking inches squared on the map, 2 inches squared on the playa. But remember, we don't want inches squared, we want feet squared. So we're taking inches squared to feet squared. We're taking, we have 12 inches are in 1 foot, but again, the exponent says that we have to square our conversion factor in order to make this work. And so now, let's look at the outcome of that. Let's check to make sure our units all cancel. They do. We're left with feet squared, which was what we want in the denominator. And so what we're going to do here then is carry out the calculations. It's simple multiplication, squaring, and it's multiplication, squaring, and division. Okay? And we're going to end up then with 32,845,084.2 feet squared. Now, the last stage in this calculation involves essentially dividing the number of grams by the number of feet squared. And for that, if we do that, we come up with 0.075282255 grams per foot squared. This makes sense. This is a much bigger number than that, okay? So we come up with a fraction that's less than 1. Remember though, we have to worry about significant figures, and the part of the calculation that determines our significant figures really is this one. It's where we had 60,900 people. If you look at this, put it in scientific notation, we have, this has 6.09 times 10 to the 4th. You can see that we have 3 significant figures. So we'll put this in 3 significant figures, which is 7.53 times 10 to the minus 2 grams of nitrogen per foot squared. And that's how it's done.